My name is Jeff Heaton. I am a Vice President of Data Science at RGA, and I'm going to be talking to you about how some of the advances in artificial intelligence that have been applied by Google to the game of chess might apply to actuarial science, underwriting, and other things that the life insurance industry might be interested in. AlphaZero was created in 2017, and it is now the most powerful chess computer in the world. Chess computers have previously beat human beings, the human champions of this game. What is fantastic about AlphaZero is that it used no human knowledge whatsoever. It mastered the game of chess in 40 hours simply by playing itself. So normally, when a chess computer is built, openings are studied, closings are studied. This is what takes a large amount of time. We've got to collect all of this data for the chess game that human experts have worked on for years and teach the computer from this. The field of underwriting and actuarial science are very similar. We've got all these rules that human experts have spent many, many years developing. Could a computer be taught to learn this completely on its own in absence of human knowledge? This could be valuable because data scientists are always asking our companies for more data. The AlphaGo team for chess needed no data whatsoever. So just to give you a history of competitive chess and how it went from humans to computers. In 1985, Garry Kasparov became the world chess champion. He became this champion by defeating another human being and winning the title. In 1997, Garry Kasparov lost to Deep Blue. Deep Blue is a proprietary chess computer that was developed by IBM, studying years and years of human knowledge in chess and learning how to most effectively compete openings, middle games, end games, all these things that chess experts are very aware of. These days, the power that was in this very large Deep Blue computer, you can have in a chess computer on your iPhone. In 2014, an open source program, so something that you can get and everybody has access to, wins the computer chess championship. Stockfish was created very similar to Deep Blue. It's based on openings, lots and lots of human knowledge, years of research goes into it. Then in 2017, the world changes. AlphaZero defeated Stockfish. And AlphaZero was trained on no human knowledge whatsoever. It simply played chess against itself for 40 hours and was able to master the game. AlphaZero was able to definitively beat Stockfish in 100 games and then went on to play some of the greatest human chess players online in a tournament staged by Google and was 100% victorious. So how did AlphaZero actually do this? And how can we use this technology to help in data science that is used in typical life insurance situations? Data is very important. Computers normally learn from data. This is machine learning. You have to have enough data to represent all of the cases that might come up when these situations are coming into the machine. This is big data. This is why big data is such an important concept. Some of these new machine learning techniques like deep learning are not all that effective unless you have a tremendous amount of data. What was powerful about AlphaZero is it was able to essentially play against itself and to move the entire evaluation into the computer itself. And now you have as much data as you are willing to throw compute power at it. Forget big data, now we have infinite data. Now this is different than a lot of life insurance problems. And we have to think about how we can move some of these problems to a situation where technologies like AlphaZero could help us. We're not there. There's no way that we could possibly master something like underwriting or some of the actuarial science functions in the amount of time that AlphaZero was able to do this. This cannot be done no matter how much compute power we throw at this particular problem. The reason for that is part of the evaluation is outside of what the computer can deal with in a situation like this. If you look at my diagram that I have here, AlphaZero, you can see that the entire evaluation process can be completed inside of the computer. This is because it can simply play against each other, against itself, against other computers. And this can all be done in parallel. You can be playing 1,000 games of chess at once and be able to evaluate that. It's simply a matter of how much compute power Google wanted to throw at it. And believe me, they threw considerable compute power at this. For an underwriting system, it's a lot more complicated. We have health concerns of individuals, and we need to see how these will play out long term. Also, underneath all of that, health advances and mortality rates are changing in the background. Smoking rates are decreasing. Longevity is increasing. All these factors cannot be simulated completely inside of a computer. The only possible way you could do this is if you think of the movie The Matrix, if you could literally simulate an entire city where you've got thousands of people carrying out healthy and unhealthy lifestyles, and the computer was able to simulate this over and over and over again and eventually learn, then we would be in the AlphaZero situation. But we are a long way from being able to truly simulate the human body down to the atomic level. So what's next for AlphaZero? Often with these technologies, you see that computers have defeated years and years of, thousands of years in this case, of human knowledge in games like Go and chess and other games like this. The AI researchers are choosing games that are very, very fine-tuned to the advantages that AI currently has. So the next challenges that they're going to take on are randomness in games. Chess is completely deterministic. There's no dice. There's no random element into it. If you move a piece to a board position, the result is completely expected. There's also no uncertainty or situational awareness in chess. You can see the entire board. It's a lot more complicated in a video game where you can't see around a corner, or as a self-driving car, you also can't see around the corner. The other big advancement that they're working towards is getting away from the notion of one-trick ponies. General AI, so that a single AI engine can do multiple things. Deep Blue was designed for chess and can really only play chess. AlphaZero can play chess and Go and a few other games, but it cannot drive a car. That is the march towards general artificial intelligence, which is creating these programs that are available to do many, many different things without being built from scratch. The problems that we face as life insurers are much more complicated than the game of chess. It's not this nice board with a few pieces and well-defined rules. We will continue to develop predictive models and artificial intelligence as we close the gap more and more between the human mind and what computers are able to do. But for now, we still rely very much on human expertise. This concludes the presentation. It was my pleasure speaking to you on this very interesting topic. If you have any questions, please contact me at the email address provided with this presentation. Thank you for watching.